Alright, we're going to start section 3.3, which is your shortcuts for all your rules that you talked about. Now, some of these are going to look the same because I've given to you the rules knowing this section was coming. The first one that you need to jot down is a theorem 3.1. Now, wait a minute. You already have this. You already know that the derivative of a constant is 0. You already know that the derivative of a linear function is the slope of the line. All I'm doing is reading the script, which you're going to have to learn to read one of these days. This one we called the power rule, where you drop the exponent and subtract, you multiply. Okay. This one is you can multiply the coefficient of a derivative by the function, and you'll get the same answer. That's what we're going to do on the first problem. Not a big deal. The derivative of a sum is the same as the sum of the derivatives. Does that rule look familiar in any way, like one you've already seen? Involving what? Limits. The derivative has a limit-based definition, so the laws that apply to limits still apply in derivatives. You can take the derivative of a polynomial term by term, just like you took the limit of a polynomial term by term. It seems common sense to you to do that, but there's a lot of reasons they have to put this down, and those will come up later. Also, the difference of a derivative is the same as the derivative of the difference. So, those are the rules that you already have, and we've already talked about. They're just on one nice, neat page. The new ones for today are as follows. Ready? This is going to go away. It's in your book.
So wait.
We've already talked about these.
What's number 4 again? What's that for?
4 means that you can factor out a coefficient, take the derivative, then multiply your answer by that coefficient, you'll get the same answer.
Okay.
All right? So, on number 2, as Alex was writing, you can take the 8, multiply it by the 3/2, and you can take the 3/2 and subtract the 1. That's one you're just talking about. I gave it to you all at once instead of in 2 parts. So this is the derivative h prime of z. Okay? On h prime of z, you simplify and you get, what, 12z to the 1/2. Watch very carefully. If you take that derivative, you get 12z to the 1/2. This notation means, let me change that to a 4. This notation means, what is the slope of the tangent line at x equals 4? This is not in the question, but this is what your quiz will be like. Your quiz will take derivatives, put in numbers, and see what you get out, and the answer will be 24. You put the 4 into the z right there. Okay? I said I made that up for Friday. On Friday, you're going to take the derivative and put numbers in to come up with slopes.
How will the numbers be in the problem? Will they be in the format like?
A point, or at x equals, or the intersection of 2 lines. Okay? So, that one was number 2, nice and easy. Moving on. Before we move on, actually I'm going to give you this rule now. If you want to take the derivative of 2 products, here's how you do it. I don't know too many people that write it like this. Most people write this. If you have 2 functions multiplied together, then the derivative is the derivative of the first times the second plus the first times the derivative of the second, also known as the product rule. I shorten it down even more than that. I say h prime equals f prime g plus f g prime. I just had a kid today in Trigg says, "Are you making that up or is that in the book?" I said, "You sound like my calculus class." Are you making that up, or is that in the book? Sometimes it is, sometimes it isn't. I don't know. I never learned out of this book. The book I learned out of was this thick. That was it. Straight old school. Okay? That's the product rule. Wait a minute. Stephanie's excited about something. Anyway, you're looking over there smiling. Okay. Oh, okay. Excellent. You can add derivatives, subtract derivatives, multiply derivatives. The fourth option? Yeah. The quotient rule. Might as well do this. Now, I'm not going to... Now, there's lots of ways of remembering this. The U of I kids didn't like this, but I don't know. Yeah. The derivative of the quotient is the derivative of the numerator minus all over g squared. Okay, that's how we learned it. It had primes and other things in there, but that's basically the idea. Oh, look, one siren, I lose 8 people. What are you going to do? Are you going to see it? No. Yeah. Can I go to my car and no. You have to stay here, learn this. Okay? Now here comes another rule. Are you ready? I don't consider this next one to be a rule, but I do consider it to be, I will show some, because in the past, about 30% of the people use this. The reciprocal rule. Okay? Does anybody notice anything about the reciprocal and the quotient? They are very much alike. If you have 1 over g and you want to take the derivative of it, this one says it is the opposite of g prime over g squared. So it goes, wow. Well, yeah, it's the same as the quotient rule because the derivative of 1 is what? 0. It's not, I mean, to me, it's not worth the mental space to try to memorize this because if you did the quotient rule, you'd have 0 minus the derivative of g because there's a 1 right here, all over g squared. There's nothing magical. It never is in math. It's just something that's a shorter way of remembering it for some people. Like I always use this, even on reciprocal problems. I just write 0 minus all that stuff. Okay? So there is some relationships. Now, on homework, tests, or quizzes, should you forget any of these rules, you can always go back to the beginning. Limit as h approaches 0 of f of a plus h minus f of a all over h. You can still go back to that. It's going to take you a lot more math. But if you forget something, you can remember it that way. For instance, the chain rule. That's the one that came up with Evan and Connor one time. They forgot it and had to expand out a binomial because they forgot the chain rule. They did it quite well, but they forgot the chain rule. Anyway, the next rule you're going to learn is the chain rule, but these are shortcuts that you must show steps on to get full credit. If you just write down the answer, you won't get any credit because obviously I'll think you got it from someplace else. So, calculator back of the book or somebody's paper. Ready to move on? Let's move on. Number 6. Is this a sum, a difference, a product, a quotient, or a reciprocal? Difference. So I'm just going to take the derivative of each one and subtract my results. Don't forget it's g prime of x equals, now some people have to write down this, which is fine. I do the same thing before they take the derivative, or they just think about it like that, which is fine. But you're going to be taking the derivative of a lot first semester, and we're taking the antiderivative of a lot second semester. I'll show you what that is in just a moment. So what did you get for this one? Hammer? Right? Right. Negative 1/4. Very good. So, that's it. That's the answer. Huh? Well, you can. I mean, if you want to get fancy.
No, it's not fancy.
Well, some people like to become fancy. Yes, I do. I play that Posh Puff game, whatever it's called. No, it's Fancy Nancy Posh game. It's a term, fancy term for fancy. Yeah, haven't you ever seen Fancy Nancy? Oh my gosh. Well, obviously the title of the book gives it away. And there's a game that goes with it, a board game. So,
Who reads this book? Why is that so Abby?
huh?
Who reads this book? Abby?
Yeah. And she has to have someone to play the game with, so I do. I'm very good at it. Okay?
Do you want to win? Or does she beat you?
No. There's no winning in Fancy Nancy. Oh my God. Yeah, through the eyes of H here. Boring. Move on next. It's just about, being creative. Yeah. H prime of X. Is this a product? Is it a quotient, a sum, a difference, or an individual power rule term?
Who knows?
The product. You can do this one of two ways. You can do the product rule, or you can simplify first. Simplify? Sounds good to me. So if I'm going to simplify to change my notation to h of x, I'd have 3x to the 8/3 if I add the exponents, minus 2x to the 5/3 plus 5x to 2/3. And I take the derivative of each one. H prime of x equals 8x to the 5/3. Again, I'm dropping the exponent, multiplying and subtracting 1. Minus 10/3 x to the 2/3 plus 10/3 x to the negative 1/3. That's it. And you can factor that if you want to if it equals 0. You're not going to do that now, but in the next chapter and later on in these sections, you're going to be saying this equal to 0 and solving. Okay? So it just becomes a polynomial for which you have to solve. And that's about it. You could use a product rule, or you could use the simplifying first. That's always an option to simplify. Okay, anything else? Great.
How did you get the 8 off first?
The 8? 3 times 8/3
Okay, yeah.
is 8. Okay. Okay. This one. On this one, I'm going to use the product rule. Okay. This is F and this is G for my notation.
You should write the one that you use.
I am. So I'm going to take the derivative of F. First of all, this is H prime of Z. I'm going to take the derivative of F, multiply by G, plus F times the derivative of G. So it'll look something like this. 5z to the 4th minus 6z squared times 7z squared plus z minus 8. That's the first two parts. That's the F prime of G. Plus F, which is z to the 5th, minus 2z cubed, times G, which is 14z plus 1. Now, right, 14z plus 1. Now, you need to listen very carefully to this, to my expectations on simplifying derivatives. This one is a binomial times a trinomial plus a binomial times a binomial. Okay? I don't expect you to multiply that out because of this part right here. If it was a binomial times a binomial plus a binomial times a binomial, yes, you have to multiply that out and combine like terms. But if you have like a trinomial times a trinomial, you don't multiply it out. You just keep it as is, okay? When you're taking the derivatives, also rarely do you multiply out denominators. Rarely do you multiply those out, so you keep those factored. So since this is a 2 times a 3, you don't have to multiply it out, okay? And if you're not going to multiply out the first one, you don't have to multiply out the second one either, okay? So you can leave that as is, that's fine. Now watch something very carefully. If you take the derivative, and I ask you this question, h prime of 1, that means you put 1 in for all of z's, and then you would multiply that out. H prime of 1 will give you negative 1 times 0 plus negative 1 times 15. So the answer would be negative 15, h prime of 1. Okay? Let's start out capitalizing the equation. All right? That usually means antiderivative, but it doesn't mean that in this case.
I thought capitals are always matrices.
No. All right. Capitals usually mean antiderivatives in calculus. Any questions? So I have the product rule. We've done a product, a power, a sum, and a difference. Quotient. Stephanie's complaining. First she spaces out. Now she's complaining. You want to get this one to go on your own? I'll give you a minute. I'll give you a minute to take off to see if you know which direction to go. I'm not going to give you a minute to organize. Just start writing and see if you can do it. Did you get it? Well, you should be able to do that. Seven. All right, I'll get caught up with you. Okay. That was the first step in solving this. Again, you rarely multiply out the denominator, so leave it squared. But I took the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator. Wait a minute, how's your book do it? This kid got really mad I wouldn't teach it like this. How does he teach it? O-D-I-D, I don't remember. I know there's some little rhyme for this. I go, I'm not doing that. If you want to rhyme this rule, then go ahead. There's some little rhyming rule in your book. He found it. I said, no, I'm not doing that. 2w cubed minus 14 minus 6w cubed all over w cubed minus 7 squared. Okay. Again, you have to multiply out this because it falls below the 2 times 3 term rule. I know, we should multiply out the last one too just for fun, but we didn't have to. F prime of w, negative 4w cubed, and obviously you're looking to see if you can factor in any way. In this one, I don't think you can. Okay. So, with that said, I think that would be your final answer. Okay? And like I said, you're going to spend a while getting good at this. So, any questions on anyone we've done so far?
Yeah.
All the rules pretty easy to remember. On Friday, you have to do these without looking at your text or without me to help. The person in my place, I have no idea if they know anything about math. Even if they do, they probably won't say anything. Ha! It gets better.
Wait, what number was that last one?
I don't know. 18 is 22. You want to try this one on your own? This one's got the power rule in with the quotient rule.
I mean, it's like power. Oh, power.
I went like this too.
All right.
So which one do you do first? Quotient and power?
You do the quotient first and the power within it.
Oh my gosh. Okay. Go ahead. Pick this one.
All right. So, we can't really simplify it. F prime of x. This is the same as x to the 1/2, right? So you have 1/2 x to negative 1/2 times 2x squared minus 4x plus 8. All your flaws for algebra will be exposed and you'll be able to work on them while you're doing derivatives. Your algebra will become so much stronger it's not even funny. It has to, or you won't be able to get through the problems. For instance, then you take minus. No, minus x to the 1/2 times 4x minus 8. All over, minus 4. I was already looking at something else, sorry. Minus 4. And you can take 2x squared minus 4x plus 8, all squared. Now, you had this problem last year, 1 year ago. How do I know that? I just did it in trig. I said, oh, this problem will come up in calculus today. So, to answer this question, what can you factor out of both of them? X to the negative 1/2 you can factor out? Yeah, you always factor the smallest exponent when you factor. Okay, so you can take out a x to the negative 1/2. What else do you have to take out? Well, you can take out 2, I guess. Sure, why not? This is going to be interesting. I haven't gone this route before, but that's okay. Now, I have my fort. That means I factored something out in my work. Yeah. Because what's left inside. If you take a 2 out, that means all those go down by 2, right? Okay. And the x to the negative 1/2 is gone, isn't it? So I still have the 1/2. I still have the x squared minus 2x plus 4 minus what does this become? Do you remember? Yeah, it becomes x. You have 2x minus 2. Nicely done. You always factor out the smallest exponent between the two. The negative 1/2 is smaller. Also, to check your work, if you're going to multiply this back through, negative 1/2 times a 1 gives you the positive 1/2 that you started with. You'll be factoring a lot of negatives. You'll get the hang of that. Yes? Well, you can take the 2 out of the 1/2, or you can take it out of this, but you can't take it out of both. So since I took it out of this one, the 1/2 stays the same, but it's going to end up being the same. All right. Still over 2x squared minus 4x plus 8. So the derivative was the first step, and the algebra are going to be steps 2, 3, and 4. Okay? So the derivative was the first step. Now the algebra is going to take over for your final answer. And it's not easy algebra by any stretch. So f prime of x The radical will go to the bottom, won't it? The negative exponent, x to the 1/2, 2x squared minus 4x plus 8. The 2 I didn't do anything with, still there. Here I have 1/2 x squared minus x plus 2 minus 2x squared plus 2x. Should I leave the 2 alone yet until I'm done in here? I think so. Negative 3/2 x squared plus x plus 2. All over x to the 1/2, 2x squared minus 4x plus 8 squared. Now I'll probably run the 2 through there and be done. Don't you think? F prime of x equals negative 3x squared plus 2x plus 4 all over x to the 1/2, 2x squared minus 4x plus 8 squared. Woo, woo. Nice. Nope. You rarely, if ever. Oh, yes. It looks kind of scary. I don't like that. Just go away. All right.
How did you manage that?
I erased half the problem.
Did you not pick up your phone the whole time?
Plus 8 squared. X. See, this is fun. If you don't have anything else to do on a Sunday afternoon, it's raining outside, do a few of these. Very relaxing. I find it very nice. Watching TV, I've gotten very smart watching TV. Every time somebody turns on, I go in the other room and do some math. Okay? It bothers me. Huh? I think it's rigged. All right.
You think it's rigged?
It
How do
is.
you rig football?
That's not hard.
Easy. Oh, I'm hurt. I can't make the tackle. Haven't you ever seen those BW3 commercials? Sprinkler comes up, there he goes. Yes, I can.
How did you get just 4x
From the derivative of the denominator.
But how do you get that?
Take the 2, multiply it, subtract 1, and then take the 1, multiply it. Or this is just the slope. You can look at it that way. Just the slope. Okay? All right, I got at least one more to do. The derivative of any constant is 0.
That's my number. It's a good number. Just end at that.
I don't want to start.
Yeah, whatever it is.
Go to 26.
All right. Graham, focus. Stop playing their hair. All right. I can tell.
This is all we just did.
No, it's not. No, it's not. You would.
Going to our game tonight?
Yep. Yeah, Parkland. Monday night.
Don't you get tired of always going and coming in doing this?
Yes, until I get my paycheck.
Good answer. How long is your Parkland class?
Wait, so the top
5:30 to 7:50. You can find a lot so you don't do this problem, right? Did you get this problem done?
Wait, do you teach the whole time?
No.
What do you do?
I do other things.
So like you give homework and then like just sit there.
No.
So your homework
The
outside
top is going to be 0.
The first half of the numerator will be 0. The second half of the numerator will be 6 times the derivative of the bottom. Okay? Now, for all those that are having fun with this, the derivative, remember, is f prime of g minus fg prime all over g squared. Yes, the 6 is a constant, so the derivative of that's going to be 0. don't really waste your time writing the denominator times that. You know why? People do, and then they carry it through, not realizing it's going to be 0.
You're not showing your work though. I feel like you're taking off the point for that.
No, because you could do the reciprocal rule. You could say the opposite of 6 times the derivative of the denominator, if you wanted. So there's the derivative of the denominator. I did the power rule here, and I could have used the linear rule here, mx plus b, and the slope is just going to be 1. All over the denominator squared.
Do we have to do the bottom part plus 1?
What?
Oh. We don't have to do the bottom right multiplier.
No, you rarely multiply out the denominator.
Why did you get plus 1? Wouldn't it be 1 minus 1 making 2?
No, the derivative of this is 0.
Yeah, but for the z.
The number in front of z is 1.
But it's no z because 1 minus 1 is 0.
Right. Yeah, z, any variable to the 0 power is 1. That's like the smallest bubble I think I've ever seen.
You talking to?
Stephanie, she blew like the smallest bubble I think I've ever seen. Must be, oh, it's because the kid's not here. That's why I can see Stephanie so well.
The kid,
Yeah.
Zach.
Zach, right.
Oh, I forgot about that.
Where is that?
He's not a call.
Okay. Hey, yeah. He's probably going to listen to this. We should give him a shout out.
Hey, Zach.
Yeah, okay, that's it. All right. We're good. Yeah.
Hear that?
Yeah.
Sure.
Absolutely. All right. Last one right here.
So wait, last one, the last one, the last one.
Well, we got to get through 29 today. Now, I'm not going to say anything. I want everybody to try this. I'm hoping that 75% of you will get this answer. That's my hope.
Wait, did you say something about it being
Quiet. You have 1 minute. This is number 30. Go. Shh. You have 1 minute to keep it quiet so everybody else can finish working. If you already had the answer, you did something wrong.
For real.
Really?
Yes.
Oh. No, got it.
It's like a wave of knowledge going through the room. Ride the wave. Hannah's like, what? Chase is like, No, that's what he did. That's exactly what Chase did.
Is there a rule for this?
There is no rule for this. It's ruleless. No, there's a rule for this. Bo almost has it. Are you done? Excellent. What'd you get for the answer, Bo?
That's what I got.
324. Not right.
I believe so.
Mr. Beard, you had that before you started typing.
That's what I got.
Most people put this. Because I want 50% accuracy. How many people got it right?
I don't understand why it's number 30.
Okay, put it down. Yep. This is actually okay. Now, watch this next part a little bit more careful. This is the alternative approach to solving this problem. You'll learn this coming up later this week. This will not be tested, but you should still know it for Friday.
I think we should have a question like that on Friday, like exactly like that.
In fact, you should just put that.
Okay.
the chain rule?
Yep, this is the one that causes people the most points on tests and quizzes. Yep. I'm going to write it F, G. It works with something inside the parentheses that you can't use the power rule for. For instance, in this case, you can't take the 4 out in front, multiply it by the 3, and subtract 1. Because it's not written, it's written with parentheses. Anytime it's written with parentheses, that tells you it's a composite rule. A composite means made up of more than one thing, like composite bats, composite, what else is there? Pads, helmets, things like that. So it's made up of more than one compound. In this case, it's made up of more than one function. So I always take f prime of g times g prime. Okay? Grizz has got this one figured out. The reason I chose this one, everybody in the room knows the answer. Okay? So this is how people later on will do the problem. On this one, they still might multiply it out, don't get me wrong. But the outside function on this one, does anybody see the outside function? Well, like 1s to the 4th is the outside function, outside the parentheses. What's the inside function? 3s. Okay? This says take the derivative of the outside, and the inside stays the same. The derivative of the outside is 4 times 1 to the 3rd power, and this 3s stays the same. Okay? Now I have to multiply by the derivative of the inside. What's the derivative of 3s? 3. Okay? It is. But what you just did can't apply to this. Okay? Yep. All right. I think I'm done. Oh, yeah, I'm done. So, yeah, we'll get through 29.
Are you supposed to be getting the same picture?
I think so.